Podcast is now starting. All attendees are in listen-only mode. All right, good afternoon, everyone, and thank you for joining us for Data Logger Basics. I am your host, Taryn Picard, and we are going to get started in just 1 minute. So we appreciate your patience, and we will start momentarily. All right, and we're ready to begin. So as I mentioned, I am your host, Taryn Picard. I'm the sales manager here at Onset. That's a lovely photo of me. Today's agenda: what is a data logger? Types of data loggers. How are loggers used? Selecting a data logger. Real-world applications. And then at the end, we will leave some time for our favorite Q&A. Little bit of history on Onset. We are a world leader in data loggers. We actually represent 2 different brands, the HOBO brand, which many of you know, and also our InTemp product line, which is more for the pharmaceutical industry. We've been around for over 35 years, so we know what we're doing when it comes to data loggers. We have over 150 employees, as well as a global network of distributors, so our loggers are used around the world. And what you see in that picture is actually a beautiful image of our facility. We are located right smack dab in the middle of Cape Cod. So I'm going to cover a very frequently asked question. What does HOBO mean? Is it an acronym? Honest Observer by Onset. Nope, it is not. In fact, you might be pretty surprised to know that it means absolutely nothing except for what you think it is. Our owner had an infatuation with trains and anything related to trains. So his thought process behind it was a hobo would travel along on a train, picking up bits and pieces of information along its journey, and be able to share that with you after the fact, just like our data loggers. And we have a ton of products that have all been named railroad themes: Stowaway, Green Line, Boxcar, you name it, we've covered it. This webinar is going to run for approximately 40 minutes. Again, at the end, we'll leave about 15 minutes for Q&A. I just want to point out that this webinar is being recorded, so feel free to watch it over and over again. But also, if we don't have a chance to get to your question, please make sure you reach out to us. We have several people here at our facility that can help answer any application questions you may have, or if you have very specific questions we don't cover in this webinar, please feel free to reach out to us. Moving on to today's presenter, I'd like to introduce you to my colleague Eileen Santer. She is a senior Onset application specialist with over 20 years of data logging experience. She specializes in assisting researchers, consultants, government agencies, and universities in a wide range of environmental applications. But I want to assure you, Eileen can answer questions even on our building performance side as well, so feel free to ask away. Eileen, I will hand it over to you in just a moment. We're going to start off quickly with a poll question. And bear with me as I launch this poll question for all of you. Are you currently using data loggers? There you are. If you could please take a moment to answer the poll question. All right, it looks like a massive majority of you are using our HOBO data loggers, so thank you very much for that. A few of you are using other types, and some of you are new to data logging, so I'm going to go ahead and close out the poll. And I'm sharing the results with you so you can see for yourself. Excellent. Moving right along. Eileen, could you please share with us, what is a data logger?
Good afternoon, everybody, and thanks for joining us. What is a data logger? A data logger is an electronic instrument, and it is going to record at an interval that you choose and give you that data over time. You'll have that time, date, and measurement that you're looking for. Typically, a simple data logger is compact. It is battery powered. It does have an internal microprocessor, storage, and a sensor or more. We have categories of indoor data loggers that can't get wet, of course, those that are supposed to be deployed outdoors, and underwater loggers that are completely waterproof. Our data loggers have memory. They are going to be set to record at that interval for a number of years based on their battery life, and you can get the data and you don't have to be there. How do you use a data logger? You are going to download and install software or an app onto your smart device or a laptop, and that's what is going to help you configure when you want it to start, how you want to name this, and choosing your interval. You'll connect your data logger to either your smart device or the computer, and you'll choose that interval. You can choose from 1 second to 18-hour intervals. That software will tell you how long the data logger will run based on that, so you can plan your deployment. You know when you want it to start, when you want to read it out, whether you want it to continue, or whether you want it to stop when it's full. You will place that data logger in the location where you want your information and set it up and let it record. All of the data loggers have battery power. Some have backup battery, some have solar power, so it's depending upon your application. After you've recorded for a period of time, you will reconnect to the data logger, either via your mobile device or your laptop, and read out that data file. There are different types of data loggers. You have a state data logger or an interval-based. What I've just described is an interval-based data logger where you are setting that date and time. It will wake up and record again as fast as every second or up to 18-hour intervals, and you can choose that. A state logger on the left is going to be used when you want to do runtime on a motor, or you want to know the on-off of a machine, an open or closing of a door. A state logger isn't going to be looking every second, but it is going to record when it senses that change of state. What that does for you is give you the information that you're looking for. You wouldn't have a huge file of data that doesn't mean anything. You will have a start and a stop, or an open and a close. Your data file is going to look a little different for a state. You'll see the opening or the closing and the duration of that information. When you're recording at an interval, you're going to have your data file, which is going to look a little bit differently, and it's going to record again every 10 minutes, every hour, whatever you choose. I think I went a little too fast. I'm going to back up. How are you using these? We have data loggers for indoors, and I will go clockwise starting at the bottom. Temperature light data loggers are available for underwater studies. Think about eelgrass studies, salt marsh studies, and they're small, about the size of a bottle cap, can be deployed in water. Moving around to the indoor CO2 data logger in the building. This is also going to give you temperature and relative humidity and carbon dioxide for indoors. It will also monitor field conditions, temperature, relative humidity. Other sensors are available, of course, for field conditions, for different areas like site selection for where to plant different crops or types of vineyards. Occupancy and light, again, for a building. Is there someone in the building? Are the lights on and off for energy studies? Moving to the right, temperature, relative humidity. and indoor data loggers. These are Bluetooth to the smart device. You can communicate to them within 100 feet of range, which is a nice convenience if you're doing apartment buildings and you don't need to disturb tenants. You can read that data logger from within 100 feet. Full weather stations are available for field conditions, and you're adding sensors that you choose. And down on the bottom at 5 o'clock, our Bluetooth water level. We have several models of water level data loggers. This one is going to communicate to a smart device, so you don't have to remove sensors, and you can again be within 100 feet of that. To specify some of the indoor measurements, environmental measurements might range from temperature, relative humidity, carbon dioxide, air velocity index, VOCs for air quality studies, power monitoring, energy studies for kilowatts, plug loads for machines such as vending machines, power factor, AC/DC current and voltage for short-term studies, differential pressure, gauge pressure. We accept 4 to 20 milliamp signals that can read from different pieces of equipment. And all of these pieces you can add to a toolbox. So if you're walking into a building and you're trying to determine some of the energy efficiency, you've got some data loggers on hand that maybe you want to leave them for 2 weeks and come back to them later and read them out and do an analysis. The time of use data loggers, again, is what I was referring to as a state logger. It will give you lights on, off, motors on, off, state changes such as doors and windows being open, and occupancy and light sensors. The light sensors do pick up all of the new LED style lights, so that is a very popular new product in the last few years. All of the indoor data loggers are designed for areas where they are not going to get wet. That means they're not going to be sprayed down in a barn or a truck. They're designed more for indoor office space. What we are showing is the 4-channel data logger and the carbon dioxide temp RH data logger, the Bluetooth temp RH data logger, a state logger in the middle, and these are all very small, about 2 inches in diameter. And here's the occupancy light logger. Why are you using data loggers? Typical users would be energy consultants and auditors, performance contractors, building commissioners, anyone who needs a device that you need to do some analysis. And again, different applications, building commissioning, energy audits. Typically, people might pack a case of a 4-channel data logger, some temperature data loggers, some AC current loggers, on, off, and they have some tools ready to do their verification. Common needs, they want it easy and fast. We do have the wide range of measurements. Toolbox, again, portability. Access to your data. The access to Bluetooth to a smart device has been very popular. We're going to be adding to that suite of sensors. Right now, I'll talk in a moment about how you're getting that data. Common needs as well. Do you have technical support and help when you're ready to choose something because you need something shipped quickly? And of course, you want it to be efficient as far as cost. On the outdoor measurements, I'm just going to check back. Yes, I did skip a little slide here. Typical users, again, facility managers, property managers. And this covers all of the applications I just mentioned. Occupancy, comfort, indoor air quality. They can be used in conjunction with a building monitoring system as backup. storage, warehouse studies, and again, common needs. You want it to be easy to deploy and reuse. You want notification on some of these if you need alarms. We have the capability of doing that, and flexible access to your data, and you want to be aware of the energy that's being used. Some of the outdoor measurements for data loggers. We have three main areas, underwater and outdoor, as well as the indoor, of course. Water temperature, water level, conductivity in freshwater and in saltwater. Soil moisture sensors, used quite a bit for irrigation studies so that you're not overusing water and using it only when you need it. Water flow, a very important aspect now, and pH. Weather parameters. Typical weather parameters include temperature and relative humidity, PAR, which is used for plant growth, photosynthetically active light, light intensity in different ranges. We have solar radiation as well. Rainfall, very popular right now. It's helping to predict and react to some of the heavy rainfalls we've been seeing these past few years. Wind speed and direction, of course. Solar radiation I mentioned, and leaf wetness. Other parameters we can measure are 4 to 20 milliamp signals. That helps accommodate some third-party sensors. Pulses are typical of flow meters, for example. Voltage signals and tilt acceleration, used in many other applications, such as cattle studies, flow in streams, doors opening again as well. Some of our outdoor measurement loggers include our full weather station, where you're communicating to a main device that is battery operated. It has a backup solar panel. It has sensors. You configure only what you need to monitor. So perhaps you're someone who's interested in just soil moisture and temperature. You can do just those sensors to configure a system and communicate through the internet and set up alarms for frost controls. Moving to the right is a microstation. It's a 5-channel data logger that has a USB input. A little bit more cost-effective if you don't need internet access. This data logger on the bottom right-hand corner is temperature and relative humidity. That's weatherproof, typically used in greenhouse applications or anywhere where you need something a little bit more robust that could withstand getting wet, rained on, or sprayed to give you that temperature and relative humidity reading. It also calculates dew point, which is a very popular item. In our bottom left-hand corner, we're showing the picture of your computer monitor with our typical USB-style data loggers that are weatherproof or waterproof. They are sealed, so they do need an optical reader. Your choice of a base station, you'd need only one. That is your connection to the computer. A coupler is available for several styles of our data loggers, so you have compatibility with many choices of data loggers for outdoors and underwater, and then you're connecting to the data logger that you choose. Why are people using outdoor data loggers? Climate monitoring, of course. Your typical users are research scientists, environmental consultants, crop consultants, climatologists, field biologists for disease modeling, pest control. Applications are ecology studies, agricultural research, of course. Animal science, I briefly mentioned. We have data loggers for heat stress in cattle, for their movement and studies on their health, for animal health. Soil studies for temperature. There are many different methods of getting compost measurements. We have Bluetooth loggers available for that. which is very nice. You can communicate again within 100 feet of that. Stormwater management for flood control. You might be doing water level or rainfall, and you want to view that data remotely so you can signal an alert or alarm. And again, common needs for these users, they need it to be durable. We have a reputation of being very reliable, easy to use, but also research grade performance. Our data loggers are typically easy to deploy and fast, low cost, and by that we compare very well to the best data loggers in the market, and flexible access on how you want to get this data. And underwater measurements, we are showing water level. With a Bluetooth device, your water level logger is in that PVC or pipe or stilling well. The top end is in air, and that is communicating back to your smart device. Moving to the right, and these three data loggers down the center that are round are our Bluetooth data loggers as well. The ratings are different as far as accuracy, depth range. They have a few different features. One has a presence of water capability for ephemeral streams. One has a temperature and light. Again, good for maybe some turbidity studies, eelgrass studies, anywhere where you'd like that fairly reliably instrument and a nice price to get your data easily. Tidbit data loggers are the round orange. They are glued to rocks in streams out west and monitoring temperature. On the far right, a HOBO water temperature data logger, rugged 5 to 6 year battery, coral reef studies, anywhere where you want to leave a data logger for a long period of time and come back in years and get that data. This is something we would recommend. Its battery is rated down to -40, and again, it has plenty of memory to leave for a long period of time. We also have conductivity for salt water. Down about 5 to 6 o'clock on the right-hand side is our conductivity and salinity. Moving to the left, dissolved oxygen and water level, which is used quite a bit for storm surges. Typical users, again, research scientists, hydrologists, environmental consultants, many government agencies, applications of our water quality, making sure there's no runoff affecting our drinking water, oceanographic research, animal health, climate studies. As far as oceanographic, I would probably pop back to just say lobster studies, the temperature and are fish habitats healthy and moving, what kind of environmental impact is happening, and hydrology, where is the water, where is it going, water level measurements for flood control and irrigation. Once again, the common needs are durability, research grade, a reasonable cost. It means getting a lot of data and covering a larger area. It gives reliable information when you can deploy a lot of data loggers throughout a pond or lake or river stream, for example, and fairly simple and easy to deploy and retrieve that data. And we have another poll question.
All right, everyone, I've launched the poll question. If you could just take a moment to let us know, what is your primary application for data loggers? And the results are quickly coming in. Looking like most of our customers joining us today are using them for building environmental monitoring, and I'll share those results with you in just a moment. Okay, and as you can see, the winner is building environmental monitoring.
Thanks. Thank you, Taryn. Well, we'll try and address all of those questions or concerns and make sure we're covering it. If you gave us a call because you had a project coming up, the first thing we're going to ask you is, what do you need to measure? And where is it? Is it inside your building? And how long do you want to do that application? I might ask you, what is the temperature range, for example, as far as low and high, whether you're in an environmental chamber, in a basement, in an attic, or plain old office space. Is it a one-time project or part of an ongoing project or part of your toolkit? And the reason we're asking those questions is because different data loggers have longer battery life, they have more memory, and more flexibility. So we would fine-tune what we have available to exactly what you want to do. And we are going to ask you, do you want to visit that data logger, or do you not want to visit it? Do you want Wi-Fi or remote data? Or is a 2-week project sufficient? And do you need other people to be able to pick this instrument up for you? Now, considerations in that as well might include accuracy. For example, temperature data loggers are accurate typically to about 0.2 of a degree C, which is about 0.5 degree Fahrenheit. Relative humidity ranges from 2% relative humidity to 3% relative humidity, and at that 3% relative humidity accuracy, those are a little bit lower in cost because the sensors aren't as expensive. And again, the access to your data. Are you comfortable plugging into a computer, carrying your laptop, and you're going to use a USB drive, or do you like the Bluetooth option to your smartphone? Or do you want to be checking on a building that's in another city and find out what's going on and do a long-term application? We would talk to you about the software capabilities, again, the battery life. You might want to consider the cost of ownership, of course, and that's, are there any renewable fees? Is it a one-time hardware purchase? How long do you expect the product to last? And is there support and help for getting this set up and keeping it running for you? A little bit more on the accuracy. For every data logger that we have, we provide accuracy specs. Someone might say to me, I want the lowest cost option. 3% relative humidity is good enough, and that can save you quite a few dollars for a big project where you'd like to deploy many data loggers, 10, 20, or 50. And so you don't need more accuracy. You're going to save a little bit of money. The accuracy spec is tested here with engineering, so we always give you a rating term, a rating curve rather, and different data loggers have what we call higher resolution. It simply means as you're tracking and you want to record a fast change, it is going to have more steps in between. And what that means, it's going to jump and show you a trend. Let's say you want to record as fast as once a minute. It will take a little time to get to a full change in temperature if you were measuring something that changes very quickly. And higher resolution doesn't mean it's going to be more accurate, but it is going to show you what the trending is. And a little bit of detail on accessing the data for your system. USB has been around quite a while now and very typical. You are plugging in your USB data logger to your computer and setting it up to start and then disconnecting. And here we are monitoring that piece. You are going to configure it and launch it. And it will say, I found this data logger. It will display the serial number. You can add a description. And you are going to tell it, I want it to start at noon today or noon on Friday, for example. And I want it to record every minute, or I want it to record every 10 minutes. The software will display how long it will take for that memory to fill, so you know you either want it to stop when it's full until you can go back to retrieve it, or you let it log until it's full. You're going to disconnect from your computer and put the data logger where you want to read them out and record that data. We typically get asked how many might you need for a space, and we do have a general range of, maybe 2,000 square feet if you were in a large area such as a museum. If you have a door, a window, a heating vent, floor to ceiling, that will change. So the more data loggers you have, the better. They each have that sensor built into them, and they are going to read fairly locally. When you're ready to go back to your site and read out that data, you are going to reconnect to your computer, plug it in, and you will see that data on your screen. Little bit of a view of what the HOBOware software looks like. We have some highlighted pieces talking about how you're setting it up, reading it out, and some choices. For your purposes, since this is Data Logger Basics, we do have a webinar devoted strictly to HOBOware and other software, so we can get you more detail, and we do have tech support that helps with any particular questions. And we'll address that a little bit more towards the end and give you some resources for that. The second way to access data, Bluetooth, has been fairly new over the past couple of years with smartphones, virtually everyone having one, and makes it easy to read those out. You're going to set it up the exact same way I just described. It's going to find it, pull up the serial number. You can add a descriptor. You can add an icon, choose your logging interval, tell it to start, put it in place, and anytime you want to see that data, you need to be within 100 feet of that Bluetooth low energy range to your smart device. It's using Bluetooth 4.0, which is pretty typical at this point in time, and you'll read it out and have your data file. You can then send and share that, and I will scroll through that so you can see a little bit more. This is your screenshot on your smart device of a temperature and relative humidity data logger. And you see that gentleman outside that cold room where he doesn't have to open that door, but he can still access that data on his device. And also we have Bluetooth water level, which is very nice because once you've done your installation, you do not have to pull that out of the water again. Some nice screenshots on how easy this is to configure this on your smartphone. You are tapping through your setups to connect. It will display your graphs, and if you want to share that, you have choices of Excel, CSV, a text file. People like our HOBOware files. You can choose that if you want to connect it to some of the other data loggers that only use HOBOware, and that could be typical for building on-off, building temperature, relative humidity, and some other applications where we're doing AC current with a USB style logger, but maybe you want to combine that with on-off. You can send this file to HOBOware so you can overlay that and view that together. So these will work together. Web-based systems are going to give you that remote access. So anywhere you can access the internet, you're logging into your HOBOlink account and you can view that data. And you're going through the same process. You're accessing your data logger, will find your serial number, you're going to name it, you're setting it up on your computer, and we're showing you an open door shot of our RX, which is used indoors for buildings, and it is used outdoors. It is an ANEMA weatherproof case. We have modules to add to that that gives you flexibility in monitoring building parameters such as kilowatt hours and temperature, relative humidity, AC current, voltage, and other parameters. And if you're doing outdoors, You can also Google Map your sites and combine this data. This is a typical screenshot of a basic HOBOlink file. Your cell device, your RX3000 with the cellular antenna. These can be used with cellular service outdoors. For indoors, you can use the building Wi-Fi or Ethernet. You just need to choose which method you're communicating. And this web-based internet gives you the option to get alarms based on a sensor parameter, such as temperature, for example. In weather station parameters, you might set a relay as well, or just add wireless sensors, which is new this year, that you can add many sensors to a weather station. And this system can also be used indoors with wireless sensors. The wireless sensors have backup batteries. So we have flexibility in this internet access and setting up and viewing a dashboard style on your computer. A little bit more detail again on some of the sensors that is available. We've got greenhouse temperatures. These are mostly outdoor pieces, but you can also do the same thing with temperature, relative humidity, voltage, and current, for example. Questions you might ask us, and pricing is always important to people. Does it need to be calibrated? Our product line for the pharmaceutical industry usually always needs calibration or NIST testing. We do offer that for temperature and relative humidity. Everything has a spec and everything is under warranty for 1 year. Any kind of regulations you need to meet or be assured that the data you are looking at, we do have that quality control so that you have paperwork if you need to make sure you display that or have that available for people. Is the software expensive? Data plans could be $150 a year to $250 a year, and for someone not to have to visit a site and that is cellular only, that is available for that internet piece. Most of our software is free. The Bluetooth is a free app. Our HOBOware is free. There's a $75 download for HOBOware Pro, which is used for kilowatt hours and some other particular data assistance for water level, for example, conductivity. Batteries. Most of our data loggers have replaceable batteries that are easy to find, or you can buy them again from us. Cables included. We will always tell you if you need an additional cable. Typically, we're talking about a USB cable, and it depends on the system that you're using. Data plans, again, are for the internet-based systems. Wi-Fi and Ethernet, there's a free plan. Cellular is the plan that I mentioned a moment ago. That could be $150 to $250 a year, and that could be for 10-minute updates and unlimited alarms. Battery life again. This drawing is showing a simple indoor data logger with a button cell battery. They typically give you 1 year and you can pop a new one in. And you're going to choose that based on the length of your deployment. If you told me I'm going to leave this in place and I need something that's going to run for 2 years, I might suggest our Bluetooth loggers. 1 year for the typical indoor data loggers, 5 years to 6 years for waterproof WaterTemp Pro, and that's a factory replaceable battery. Product support, yes. We have been in business, as Taryn mentioned initially, I think for over almost 38 years. We know data loggers. We are a long-term solutions provider, and we do have application notes, online resources, tech support from 8 a.m. to 8 p.m. Eastern Time. We have a users forum knowledge base with application stories, and I will click forward. I think we have a little bit more detail on that as well. We're going on into just a typical indoor environmental monitoring application for a building. This particular application was water damage, and last year in Houston we had flooding. This one is an example, and most of these have detail on our website, these stories. So you had some water damage, and in order to remediate this building, they needed to do some monitoring for a period of time and monitor that temperature, relative humidity, and dew point for mold prevention. The solution was the Bluetooth temperature relative humidity data logger. Once they deployed this up at the ceiling in any sensitive areas, they just needed to be within 100 feet of this, and they could record, and they did, every 10 minutes for 2 months. That continuous logging captured the trends. They could tell when there was a rainstorm, if there was leakage, and what the solution was going to be. This was a reliable method for this. Pricing on that data logger is about $135 in case you are interested, and they are on our website, those prices. Again, we briefly discussed they had an easy time launching it, wirelessly downloading that with a mobile app, and again, that is free. They were able to come up with a solution on what needed to be replaced and what they needed to do in what areas because they had the data to back it up. This was and is a typical energy use. A lot of commercial buildings are charged a peak demand rate. So this was a printing facility. They wanted to view the data remotely. They wanted to lower their energy costs, and they chose the remote data logging system so they could put it in place and just log for a period of time to see that data. Again, they got the RX3000 for monitoring and attached it to their pulse output on their electric meter, and they could see when machines were running and if they could readjust the times those machines were running so that they were not running at peak demand to reduce their energy costs. Data is accessible from any computer, any browser. They recorded every 2 minutes, and they got an alarm when the limits were exceeded. The result was a cost savings, and they felt they got payback within 2 years on the price of that system, learning how to time and adjust their machines to manage that energy use. Water monitoring applications. This is a picture of lovely Cape Cod, and we are surrounded by water. I'm going to talk briefly about this particular application, which is Rodeo Creek in Oregon, and they had changed the pattern of the water flow in the 1900s, and they were trying to provide a better habitat for native fish. At times they were recording temperatures up to 80 degrees, which is not happy for fish. This was native Chinook, and they wanted to support that healthier fish and beaver population. So they chose, and this is a long-term study, they chose the WaterTemp Pro V2 because it has a 5 to 6 year battery. The cost is $129 each. They could deploy many of these at the areas where tributaries were coming in, where there had been some excavators, and they were creating some new connections between springs to provide that data over a period of time and see if making those changes was lowering the temperature so that they got better conditions for those fish. They were charting the stream flow and temperature information from that data. They did determine it was effective. It was lowering the stream temperature. This was an ongoing project that is still constantly being monitored, and it was a successful project. One of my favorite pictures for climate monitoring is glacial studies. And this is a temperature relative humidity Bluetooth data logger. And they wanted to map a farm for temperature and relative humidity. This is used maybe for site selection. For grapes, for example, different varieties in the East Coast can withstand colder temperatures. And by monitoring their sites, they could choose a variety that would be appropriate. These are also fairly inexpensive data loggers, about $170 for a temperature relative humidity Bluetooth. They could get close enough again within 100 feet. We do have USB style data loggers as well. We will recommend solar radiation shields when in sunlight for particular areas. So all of that is available based on your particular application. But these are easy to deploy in an area. Valleys, mountaintops, frost, you are going to get data in specific areas so you know what is the best variety to plant. A little bit of a close-up on this particular data logger. The other nice thing is no cables. So if you're running a tractor through, and animals and critters also chew on cables, so when you are in need of a cable sensor, we suggest protecting that. And this particular data logger, again, is accessed via Bluetooth to your smartphone. They did map their temperature and relative humidity in dew point. This particular picture in the bottom left with the white data logger is the USB style that uses the base station, and of course our weather station on the bottom right-hand corner. This is our newest HOBOnet system where we have added wireless sensors to our outdoor weather station. And I briefly mentioned earlier, these wireless sensors can also be used indoors for temperature and relative humidity, for example, with backup battery power. They have good line of sight communication even in a building. Typical field studies have been 1,000 to 2,000 feet, just depending. So we're getting good communication even in a building with backup battery, giving you that access remotely. Bottom left-hand corner is showing you a temperature data logger that can be put in different areas of where you need temperature only. You're going to choose whether you need relative humidity as well. And these are run on AA lithium batteries for indoor use. A little bit more of a picture of that field study and some of the resources we have available. I briefly mentioned application stories. We have quite a few based on your market. So since we have a few building managers interested in indoor logging, you could choose your market and see some examples of some different indoor applications and what was used. I'm sure you'll find that appropriate. We have a knowledge base that answers lots of typical questions, and you can always take a look at that and do a search. Solutions, and again, searching on the website, we try and take you right there so you can easily access and might give you some ideas for future projects. And I've got to back up because I missed that last little piece. Webinars and courses, this one will be recorded, but we also have some excellent self-guided training courses on HOBOware, on HOBOware Pro, some data assistance, nice screenshots of using some particular data loggers that I think you'll find helpful. You can sit down, watch them at your leisure, stop and start them, so that we're giving you some resources you can easily access and some scientific white papers. And Taryn, do we have any questions?
We sure do. So Eileen, if you could first start off with talking about a two-part question. So in general, what are the recommendations Onset gives for as far as where to place a data logger in a room? And then the second part to that is if you could speak a little bit to our Bluetooth data loggers and how they may transmit through material.
Good question, and we do get that often. Any area that you are concerned about, let's say you're a museum with an object, an art object that you have under a contract, you want to put a data logger near it. If you're concerned about the temperature of a machine, is it operating correctly? Is it hot? Or comfort for an office space? You've placed that data logger fairly locally. The data logger sensors are built into them. Airflow, windows, doors, fans, all of that will affect reading. Typically, we would say if you put two data loggers side by side, they are both going to be reading within their accuracy spec. But if one happens to be in airflow of a door opening or a fan and floor height to ceiling height, they will read slightly differently. It means they are accurate, and they are giving you a true reading. As far as materials and Bluetooth loggers, testing one out is always a good idea. Anything like a brick wall or a metal wall might pose a problem, but you can add some routers if you were using the indoor internet based to have it hop and get around an object. The other possibility for indoors is we've tested them here when we first came out with the simple Bluetooth temperature relative humidity data loggers. We put them inside a metal file cabinet across the room, and it communicated. Now, if you have a very heavy, thick concrete wall that is insulated and covered with metal, you want to test it, and you may need to move it to get access to that. So it is dependent upon your particular application. Do we have any other questions?
Thank you, Eileen. And I'll start off by clarifying this first question. When we talk about our remote monitoring station, it is available with 3 different options. It is not interchangeable. So we have an RX3000 remote monitoring station that can either work with your local Wi-Fi. So the best way to test that out where you're thinking about deploying that type of a station is simply just take your own laptop to that location and see if your own local Wi-Fi reaches that spot. Same with an Ethernet. You would just plug in your own Ethernet cable and use your local internet to support that particular station. Then the third option would be the cellular-based option. And since our data plans are only available for GSM, that means you would need an AT&T or T-Mobile provided SIM, which our data plans we offer. It doesn't work on Verizon. So if you have Verizon service in that area, unfortunately, it wouldn't be necessarily adequate for our station. So with those 3 remote monitoring stations, and again, they are each different, they have the ability to work with our HOBOnet wireless sensors. So to answer several of the questions I'm seeing come through about our HOBOnet wireless sensors that are specific to the RX3000 station, those work on what is a 900 megahertz wireless communication. And I'll have Eileen talk a little bit more about what the distance is between those wireless sensors. Again, that's our HOBOnet wireless sensors that work with the RX3000 station. What is the distance that those can get?
Oh, I think we've experimented and we've gotten 2,000 feet line of sight.
And can you talk a little bit about how they work? Is it a mesh network? How do they operate?
they are going to communicate back line of sight either to another sensor or back to your main device. You can do 5 wireless sensors back to your main RX stations, and by that I mean hops. You could have as many as 20, and maybe you're setting them up in a pattern like I have described like a Conestoga wagon wheel in the past, and the farthest sensor might make 5 hops back to your main station. You may need to add a router in between, and picture a spider web where it is hopping maybe around a barrier. If you're trying to do a warehouse and you have a wall in between, you may have one sensor hopping, and you could get 1,500 feet, 2,000 feet to that router, to another temperature sensor, for example, and once again back to your main device. So you have the option to move your main RX station, which has what we call a wireless manager plugged into it, and that is an option you can add at any time. So you can configure that and move things around until you see that you're getting your signal.
Perfect. Thank you, Eileen. And as Eileen mentioned, and to answer a few more of your questions, this system can be used indoors. You are right for pointing out, what about the solar radiation, solar panel on the front? That's okay. You would simply disconnect the solar panel from the small HOBOnet moat inside, and then swap out the rechargeable batteries with lithium batteries. You should see about a year's worth of life out of those batteries in doing so. We don't currently promote it as for indoor use, but we have a lot of customers using it indoors and having great success with it. So it is something you should see being updated on our website in the near future, talking about the indoor applications. So I do see a lot more questions coming in, and I do apologize if we haven't had a chance to get to your question. I want to again encourage you to reach out to either our application team or to our technical support team if we didn't get a chance to answer your question. If you already have your data logger, please contact our technical support team. If you're thinking about buying a data logger and you have application questions or product related questions, please contact our sales team and our application specialists here at Onset. We would be more than happy to assist you. A lot of you are asking very application specific questions, and they are excellent questions, and we definitely can provide you with assistance. So please reach out to us. We'd be more than happy to walk you through it and really give you the very specific guidance you will need for your application.
Thank you very much for joining us today. Again, we have some contact information here for you, and appreciate you joining this webinar. We will certainly get back to you as soon as possible with any questions. Thanks very much.